Today, we are going to begin our topic on Laplace transformation. It's a tool that helps us solve difficult problems more easily, especially in engineering and mathematics. Imagine you're trying to solve a hard puzzle, like a messy equation filled with the derivatives. The Laplace transform turns the complex puzzle into a simpler one, kind of like changing a complicated math problem into basic algebra. Once you solve the simpler version, you can transform the answer back to the original problem using the inverse of the transformation. Before we go any further, let's take a look at the basic definition of the Laplace transformation. Formally, the Laplace transformation of the function f of t is defined for t greater than or equal to 0 is given by this integral. Here, s is the complex number and the transform exists if the integral converges. This is a mathematical tool that helps us to convert a function of time into a function of a complex variable s. And once we solve it in the function of complex variable s, we can convert it back to the function of time using the inverse of the Laplace. Let's begin our discussion with the most basic transform, the Laplace transformation of a constant function. Let's consider f of t equals to 1. According to the definition of the Laplace transform, we get this expression. By substituting f of t equals 1, we arrive at this new form. Now we are going to integrate this expression. As we can see, it is defined as a definite improper integral because it has an infinite upper limit. To handle this, we will introduce a limit. So to write it in such form, limit of t approaches infinity. So to rewrite this expression, we're going to be doing this. This allows us to evaluate the definite integral over a finite interval first, and then take the limit as the upper bound b approaches infinity to ensure convergence. Now we are going to perform simple integration of the exponential function. We know that e power minus infinity equals to 0 and e power 0 equals to 1. So e power infinity is 0 and this is going to be 1. This means that this is entirely going to become 0 and we are going to be left with positive 1 divided by s. So to summarize this, the Laplace transform of a constant, for example, 1, is going to be 1 divided by s. Now let's assume that it is a constant such as 2 or 3. Then the Laplace transform of those functions will be equal to 2 divided by s and 3 divided by s respectively. Let's move on to the Laplace transformation of a variable such as t. Assuming that f of t equals to t, substituting this into the definition here and here, we are going to be rewriting this expression as this. To solve this integral, we will use tabular integration and eventually apply the upper and lower limits. So to apply the tabular integration, you'll notice that when we apply the upper limit, we get an intermediate form, infinity times 0 form. E power minus infinity becomes 0. To resolve this, we will be converting it to 0 by 0 form or infinity by infinity form, and then apply the L'Hopital rule over here. However, we note that when we apply L'Hopital rule, the expression is going to approach to 0. So we are going to be taking this entire term as 0. Next, let's move on to the lower limit. We can see this is 0, and e power minus 0 is going to be 1. Here, e power minus s times 0 is going to be giving us 1. So we are going to rewrite our final expression as this. We are only left with this, which is not 0. So that's what we are rewriting here. So to summarize this, if you're taking the Laplace transformation of t, then it is going to be 1 divided by s squared. Now, let's assume that we are taking the Laplace transformation of t power n, meaning the n can be any positive integer, for example, 2, 3, 4, and 5. Then its general formula is going to be n factorial divided by s n plus 1. So for example, if it was t power 2 and we had to find its Laplace transformation, then it would have been 2 factorial divided by s2 plus 1, meaning 2 divided by s cubed. If it was t cubed, we had to find the Laplace transformation of, then we would have done 3 factorial divided by s power 4. Let's find the Laplace. Let's find the Laplace transformation of e powers 80. Using the standard definition of the Laplace transformation, we are going to get this result. Now, since the bases are same, meaning that both are exponents, we can add the powers. Now, keeping this in mind that after the integration, we will get an exponent. And because e power positive infinity is going to be giving us infinity, we are going to be taking negative sign common here, because when we will be applying the upper limit, e power negative infinity, it yields 0, which is going to be giving us a finite answer. So let's rewrite this expression. Integrating this exponent, taking exponent as operator and this in the box. So e power negative infinity becomes 0, meaning that this entire expression is going to become 0. This is going to be leaving us with this final answer. E power negative 0 is going to be giving us 1. So the final answer is going to be 1 divided by s minus a.